This video is to go over homework packet 2D 2.16. So problem number 4 says which of the following statement is not true about the quadrilateral in a plane. So I want you to remember the definition of quadrilateral, which is you have to have 4 segments, and you also have to those 2 endpoints has to meet at the other endpoint like that, and also each endpoint actually shares 2 sides. That's the definition of quadrilateral. And also I want you to think about other properties as well, such as angles. You have 4 angles. If you add all together, what would that? How many degrees would that be? Or you want to think about the diagonals as well. So that's going to be a big hint for problem number 4. Number 5 through 8, we got to review these 2 theorems, triangle angle sum theorems, and also hypotenuse and legs theorem about trapezoid to answer questions 5 through 8. So triangle angle sum theorem says in any triangle we have 3 angles. If you add these angles together, for example, like 30 degrees and 60 degrees and 90 degrees, if you add these 3 angles, then it should add up to 180 degrees. That's the triangle angle sum theorem. And this number can be any numbers, but as long this number has to add up to 180 if you change it, if you change that. And also hypothesis legs theorem means that, for example, if you have any triangles, that angle, that segment has to be shorter than the sum of these 2 segments. So for example, if you have, let's say, 2 and 3 and, for example, 5, this 5 equals 2 plus 3, and these 2 legs are actually equals to 5, so there's no way that you can draw triangles with 2 inches, 3 inches, 5 inches. If you try that on your piece of paper, you'll find out. That number has to be less than the answer of these 2 by adding, so the sum. So the number has to be less than 2 plus 3, which is 5. So that number, for example, have to be either 4 or maybe 3.5, or as long as less than 2 and 3 and greater than 0, then you can draw that kind of triangle. That's the hypotenuse legs problem, which is the second dot of that problem. So knowing that, let's just move on to the next problem. It says number 5 says the sum of measures of the angles of the quadrilateral is always true. I mean always 360 degrees. Explain why this is true. So I'll give you a hint for that. Number 5, how about the diagram of any quadrilateral like that? How about this? Did that ring your bell? How about number 6? It says is the sum of the measure of the angles of a self-intersecting quadrilaterals always 360? Explain. For example, this is self-intersecting quadrilateral, right? What do you see here and here, right? Number 7 is the sum of measures of the angles of a skew triangle. Skew triangle is the one that has in 2 different planes. So for example, if you draw a quadrilateral on a piece of paper, this is not. Then fold the paper so that this quadrilateral will be in 2 faces. Is that still true? That's number 5 through 7, and number 8 is take it further problem, so I'm not going to explain.